Okay, so hello and welcome. Howdy. Have another problem here from LeetCode to take a look at. Let's see how we do. So this problem is find largest value in each tree row. So I think I know what this is going to look like. Let's give it a shot. Actually, the next one is the one that's on my mind right now, because I think I already know what to do for this. Largest value in each tree row, given the root of a binary tree, return an array of the largest value in each row, zero indexed, of the tree. So we kind of just did a problem like this just a few moments ago. I already kind of know like what I want to do, and I kind of thought about this problem already. I kind of briefly, I sort of looked at it already, sort of in that I looked at it, sort of, I don't know how to express exactly. I mean, the title of the question is kind of gives it away. So, but yeah, so we'll do it this way. So you're gonna have a depth value as part of the state, and you can have a well, actually, you can start off at 0. I'm not sure exactly what the depth will be initially. So that'll be part of the state, and then you also have our return vector. We're going to use ret, or ints rather, and you're going to have a DFS search. So we're going to do depth first search through the tree, and I'll explain what we're going to do here. So tree node, oops, R. So if not R, then return, right? And we say the depth is going to be incremented by 1, and then we're going to call our function. This actually I don't think returns anything. Well, actually with the return statement here, that should be fine. So depth first search, what you would normally do is you would do depth minus equals 1 here, and then you do depth plus equals 1. You would modify the state in each case. When you perform a depth first search, you basically have the function sort of base cases at the top, usually typically exit cases to base cases. Then you have a loop where you modify the state. You loop over every child, modify the state before executing the child, which is a recursive call on the neighbor. Really, usually it's like a neighbor node or child node, and then return the state back to what it was before you executed. That's kind of like the general pattern. But actually, the way that we're doing this, we don't need, because this is redundant, and because this was only 2 children, we actually don't need to. We can leave this out. So, yes, you R left and F and R right and F. We're going to call it DFS of root DFS. And what we're going to do with our return vector is we're actually going to say, given this depth now, and it doesn't matter if it's 0 or 1, I'm actually not sure, we should say if the depth is greater than ret.size, then we're going to push back. It's actually we're going to push back a value. We'll call that int. We're actually going to push back, we're going to push back our value initially. Otherwise, if the depth is 0 and it's greater than the size, which it would be initially, then we push back right. Okay, that makes sense. Yeah, and then we say if. Otherwise, we say x equals ret of depth. And we say if. Well, really, it's really more like this. It should be ret of depth should be then equal to the maximum of ret depth of itself and the value that we're looking at now. So we get the largest value. And we just need algorithm, I think, to use that. Don't know if that's algorithm or math or what have you. And I think that's all you need to do. and then you can return ret. I think that's it. Let's see how we do. How much time we have here? 5 minutes? Okay. Runtime error. Nice. Nice. Oh, excuse me. Greater than or equal to. That's the way to do it. Yeah. Okay. I think that's it. Let's try the different cases here. 1, 2, 3, 1, 1, null, 2, and then empty. I think we're okay doing it this way. All right, so I think we go for it. I think so. Yeah, I think so. Nervous. Okay, not the most efficient. It's kind of interesting. I was expecting this to be actually one of the more efficient ones. But yeah, pretty straightforward. So basically you do like a depth first search, and you modify the state for the depth, and then you have a vector of return values, and each time you see a value, you know what the depth is that you saw that value at, so you can actually modify the array at that depth accordingly. And let me try it one more time to see if I can get a better time. I'm going to change this piece of code. Okay, 12 milliseconds, a little bit faster. I'm going to change this piece of code because you can do it a little bit. Excuse me. I think a compiler would probably optimize this. Probably don't need to do this, but this is technically a little bit better. Excuse me. Excuse me. Whoa. I think compilers can optimize this a little bit better. I don't know. Maybe it's just random. What number? Ooh. Okay. We'll wait a few more seconds. This is like a relatively straightforward question. I don't know much more. Have more to add here, so I think we'll just give it 7 minutes and call it. See if we have. Yeah, I think that's it. I don't know. I don't know how to make this faster than this. There might be a way to do it, but I don't know it. Yeah, I don't know. Kind of interesting that this didn't seem to speed things up very much. I think this is better. We'll leave it at that. I'm just thinking there's a different way to do this. I don't know. I mean, 8 milliseconds is pretty good. I don't know. That's all I got. That's probably the best I got. It's probably the best I got. Apparently there's a better way to do this though. That's okay. Okay. So thank you for watching. I'll talk to you soon. This one's kind of straightforward. It's kind of simple.